All right, ladies and gentlemen, here is Ms. Suko's exemplar for our Unit 6 study guide for our test tomorrow. Looking at number 1, it says find the exponential function from the table below. Hint, use exponential regression in your calculator. So my x values are going to be in my L1 and my y values are going to be in my L2 when it comes to my calculator. So open it up. A good practice is just to clear it. Second plus 7, 1, 2. Clears my calculator out. Go into stat, edit. My L1 data is going to be my x values, 1, 2, 3, 4. My L2 or my y, 1, 3, 9, 27. Exponential regression means that I'm going to click stat again, over to calculate, scroll down, and you'll see exponential regression is number 0. Enter. And it calculates my equation for me. My A value is 0.33. My B value is 3. Writing my equation out, y equals A times B to the x. That's my normal equation, plus it gives it to me in my regression. Substituting in my values, y equals 0.33 times 3 to the x. Number 2, which is the graph of y equals 1/3 times 3 to the x. I'm going to start to do a couple of things before I graph it in my calculator. Looking at my b value of 3, that means that this is going to be a growth equation. So looking at f, h, and j, all of those do not represent growth. Therefore, I could eliminate down to g. Another way you could have done this is just match the equation in your calculator. Moving on to number 3. Ooh. Growth or decay when it comes to this first equation. This b value is 2, that's greater than 1. This represents growth. The domain of all mathematical exponential equations is always going to be all real numbers. You can even check that in your calculator. Our range values, when I graph it, 5 times 2 to the, make sure you use the caret button underneath clear, x, graph it. My asymptote value is going to help me determine the range. My asymptote value is this plus 0 at the end here that I see. Because if you see in your graph, the curve will not cross at y equals 0. Therefore, all my range values are going to be greater than that. Y is greater than 0. And it's not going to be less than 0 or greater than or equal to 0 because 0 cannot be one of the values that y is. My y-intercept I can find using the table of values. The y-intercept is when x is 0. And if you see 0, 5, that's my y-intercept. You also know that your starting value or your y-intercept is your a value when c is 0. So this is also my y-intercept. Only when c is 0 though. Your asymptote value is y equals 0 or the x-axis. I'm going to let you guys do these other two based off of what we did right here in this first one. Looking at number 4, this is when we're given the graph and not the equation. Because this curve decreases going from left to right, this is a curve of decay. I don't know why it's not focusing. There we go. It is decreasing from left to right. The domain is all real numbers. The range is going to be where the graph flattens out. The graph flattens out at this asymptote line, which is y equals 3. So I can already fill out my asymptote value is y equals 3. This asymptote value is going to be my minimum value for y. All my y values will be greater than that. So my range is y is greater than 3. My y-intercept, the point where the graph crosses the y-axis, is at 0, 4. I'm going to let you guys do the other two on your own. Number 5, a family of birds just settled outside of Uplift Luna. Originally, there were 5 birds. Each day the number of birds doubles. Write a function that models the bird's growth. My initial amount was that there were 5 birds. Is this growth or decay? The population of birds is doubling, therefore this is going to be growth. The rate as a decimal, that's when this is a when this is a percent of values. So each of the birds are doubling. So my b value is 2. Writing my equation, y equals a times b to the x plus c. My a value is my starting value, which is 5. My growth rate is 2 to the x. You could put that plus 0, but you won't see it like that on your EOC. Number 6, the initial value of an exponential function is 1.8. The rate of growth is 4.2%, which models the value of the function y over time. My initial amount is 1.8. This is growth. It tells me in the problem. 4.2 is a percent. Move the decimal place 2 places to the left, add a 0 in front. There's my decimal. Because this is growth, I'm going to do 1 plus r to find my b value. So 1 plus 0.042 is 1.042. Now I can write my equation. Y equals 1.8, 1.042 to the x, which gives me c. I'm going to let you guys do number 7. Be careful, this one is going to be c, or this is decay. Therefore, you'll do 1 minus r to find your b value. Number 8, Ms. Bacon just purchased a new Tesla. The car's value over time can be modeled by the exponential function right here, where y represents the car's value and x represents the number of years that have passed. What does this 0.88 mean in the equation? Well, 0.88 is less than 1, therefore we know this is going to be a decay problem. The car is decreasing in value. So the rate at which the car increases in value, nope. The rate at which the car decreases in value, let's hold on to that one. The starting cost, no, the starting cost would be this 45,000 in front. That's my A value. My B value is my growth or decay factor. The cost of the car after 3 years, it said nothing about 3 years in the equation. So therefore, our answer is number 2. And I already said, for part B, what does the 45,000 mean in the equation? The starting value of the car. How much will her Tesla be after 7 years? We're going to plug in the equation into our calculator and use the table to find where x is 7. So going into y equals 45,000, 0.88 to the x. Make sure you put your x in parentheses. Second table, when x is 7, y is 18,390. Excellent. Moving right along. The first year of a charity walk event had an attendance of 500. That first year sounds like it's the starting value. The attendance, y, increases by 5% each year. Write an exponential growth function to represent this equation. The initial amount, 500. Growth or decay, it says increase. The rate as a decimal, I have 5 is my percent. 1, 2 makes this 0.05 as a decimal. This is increasing, so this is going to be 1 plus r rather. So 1 plus 0.05 gives me 1.05. That's my b value. Writing my equation in the form a times b to the x y equals 500, 1.05 to the x. You could say plus 0 if you wanted to. How many people will attend in the 10th year? That's part B. So I want to find when x equals 10. What does y equal? So I'm going to plug my equation into the calculator that I found in the 4th step, and I'm going to use my table of values. 500, 1.05 to the x. Table of values when x is 10, y equals 814.45. Now, if we're talking about people here, it makes the more sense to have a whole number. This is closer to 814 people. And Masuko should have paid closer attention to number 10. It says the population of a small town was 3,600 in 2005. The population, I'm going to say the population decreases. I'm going to make you guys do a decay equation. It says, what will the population be in 2025? Think about that value. From 2005 to 2025, that's when 20 years have passed. So that's going to be your little hint for this one. But again, I want you guys to do decreases instead. Okay? Excellent job, guys. Let me know if you have questions.